Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our beginner data science and machine learning bootcamp. In this course, you're going to learn how to use Python to build sentiment analysis with unsupervised classification. So you're going to learn how you can build a machine learning model. We're going to learn how to use not only Python, but also pandas, NumPy, Matplotlib, and scikit-learn. These are very popular libraries for machine learning and very important that you learn. In this lecture, I'm going to introduce for you the project that we will build together. All right, so we are going to take a data set of reviews, neutral, negative, and positive, and we're going to teach a machine learning model, an algorithm, how to cluster the reviews into its three distinct groups. We're only going to give our model the reviews, and the model is going to learn how it can separate these reviews into three distinct clusters. It's going to be quite an amazing feat. So first we're going to create this data set, then we're going to vectorize our text, meaning we're going to take this English representation and we're going to turn it into a representation that a computer can understand. So we have to turn these sentences into vectors. After that, we're going to then be able to build a word cloud. This word cloud is going to show us the frequency of the words that appear in all of the reviews. So we can actually visualize the frequency that words appear in the data set. The bigger the word, the more times it appears. Then we're going to jump into machine learning and using our process data, our vectorized text, to actually build a machine learning model. So what we're going to do is first reduce our data's dimensionality with a technique known as principal component analysis. This is going to help us reduce model overfitting, and we'll talk about what all of that means when we get there. Then we're going to perform unsupervised classification with a machine learning technique known as k-means clustering. So we're going to get this result here, you can see on this graph, where we have three distinct clusters, and all of our reviews have been sorted into three distinct clusters. So even with a small data set, we're going to have this powerful result where our machine learning model is going to be able to separate our reviews into three clusters. And it does that by plotting all the reviews based on their vectorization on a graph, and then it can find clusters on that graph. All right, so this is going to be our project. You won't need any prior experience to follow along. We'll include for you an introduction to Python and machine learning in case you are a complete beginner. That's totally fine. To build our project, we're going to use Google Colab, which you can find at colab.research.google.com. This is a free online code editor, and it allows you to code in Python on the web. So even if you don't have a code editor, that's fine. Just follow along at this website. It's completely free. You don't need to download or install any software. I'm very excited to get started, so jump on into the next section. Hello everyone, and welcome to our machine learning course. Today, you're going to build your first machine learning project. If you have no machine learning experience, that's totally fine. We're going to tell you everything you need to know. All that you will need is some Python experience. First off, we are going to do a bit of theory about machine learning so you know what you're jumping into before we build our beginner project. The first question we have to answer is, what is machine learning? All right, so let's talk about what is a machine learning algorithm. Well, this is an algorithm that can learn from data. So it is a piece of code that can learn from the data it's exposed to. Machine learning seeks to answer several questions, two key questions. Number one, how can we build computer systems that automatically improve with experience? And also, what are the laws that govern all learning processes? these are the two fundamental questions that ever since machine learning was started as a field, this is what the field is seeking to answer. Let's look at some examples of what machine learning can do. One example is an algorithm can mine through historical medical data to learn which treatment you might best respond to based on your medical data. So you can learn from historical data to make predictions and classifications about the present and also the future. Another example of machine learning in action in the real world today is machine learning can build search engines that automatically customize to your interests. So that's why you see recommendations based on what you've previously searched or even just paused during your scrolling. As well, another example is designing autonomous robots that can learn to navigate from their own experience. So designing machines that can move on their own and improve on their own without any human intervention after the algorithm has already been designed. When should you use machine learning? Well, one case is when the software is too complex to manually design. Because as a programmer, you can only go so far because some software is just too complex. For example, how would you write the software to describe an image? For you to do that with your own algorithm, to learn how to find different commonalities between faces or other images, that software is quite complex. So instead, you write an algorithm to write the software for you. Another time you should use machine learning is when software should change after it is released. For example, you could build a self-driving car, but that self-driving car is only going to be somewhat good when you first design it because the car can then learn from its experience out in the real world after it's been designed. So that is another example of when you should use machine learning, when you want your software to potentially change or adapt or improve after you've already launched it. And with machine learning, your software can actually improve without your intervention. It can improve on its own. Now, there are three branches of machine learning: supervised learning, unsupervised learning, and also reinforcement learning, which is a combination of the two. All right, let's talk about next the workflow of a machine learning project. So here is the workflow from start to finish. First, you will gather your data. And this can be quite a large phase because there's a lot of data out there that you can use that's open source, free to use. But often you'll find data is quite noisy or messy or in the wrong format. And so that's when you move to the next phase of pre-processing your data. So you have to get your data cleaned and ready for machine learning. Then the next step is training your data and feeding it to your model to train your model. And after that, you test the model. And this training the model and testing the model, this is highlighted here because it's part of what's known as a model parameter tuning loop. So this is where your machine learning algorithm learns and improves. You will train it and test it and then repeat, train, test, and you keep improving the training with every iteration of this loop. You train, then you test, you train, then you test. And then finally, once you have built a model that is smart enough or efficient and also effective enough for your liking, then you will deploy the model. So you'll send it out for production and for use. And that is an overview of what is machine learning. We're going to do a bit more theory coming up before we jump into our project. So head on over to the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned what is a neural network, and in this lecture, we're going to answer the question, what is unsupervised learning? This is a subset of machine learning. It's a branch of machine learning, and it happens to be the project that we're going to build. Our project is going to consist of both unsupervised learning and a bit of supervised learning. We'll talk about both. All right, let's first talk about the applications of unsupervised learning. There are many applications of such types of machine learning models. For example, in recommendation systems for recommending purchases or videos, as well for grouping customers based on their attributes in order to decide who's more likely to purchase something else. As well, in genetic and species grouping, this type of machine learning model is commonly used, and to distinguish between different kinds of tissues, just another practical example. More applications of unsupervised learning are to create a customer persona, to determine will this customer buy item B if they bought item A, and to detect bot activity. And even more, you can recognize handwriting with unsupervised learning, as well as speech. You can create speech and tag parts of speech and translate text. So across all types of different mediums, you can use unsupervised learning to solve a lot of problems. So now that we know some applications, let's talk about what unsupervised learning is. Well, machine learning can be broken up into 3 branches: supervised learning, unsupervised learning, and reinforcement learning. And deep learning and neural networks, they can be found in all 3 of these branches. So let's talk about supervised learning first, because we're actually going to have a little bit of supervised learning in our project. Our project is going to be mostly unsupervised, but then with some supervised learning. Supervised learning is a type of machine learning, and it learns a function to map an input to an output. It does this by using sample input-output pairs. So we're using labeled data in supervised learning. That's why it's called supervised, because you're going to train your model with labeled data. For example, if you're training your model to determine between cats and dogs in an image, then you're going to label images. This image has a cat, this image has a dog. And your neural network is going to use that label data and those labels to learn. This is different from unsupervised learning, where you don't use any labels, which is why it's called unsupervised. This type of machine learning model looks for new patterns in data with no pre-existing labels. So the neural network is sent loose on its own to find new patterns. So this time, if you're trying to perform the same project of trying to classify images into cats versus dogs, your neural network would go off on its own to find patterns in those images. This type of machine learning model requires minimal human supervision, because your model is just going to look for features in images that can distinguish them from each other. So it would say, oh, these images have whiskers and pointy ears and small figures, whereas this image has larger figures with a different body shape. And so it would separate the images on its own. It wouldn't say cat versus dog because it doesn't know the labels cat versus dog, but it would still find ways to group the images into 2 separate halves. And it would do this without the labels. There are 2 parts to unsupervised learning. There is principal component analysis and cluster analysis. So let's break down these 2 types of analyses. Starting off with principal component analysis, here is where we're taking the features of the input, such as feature 2 and feature 1, and we are plotting them on a graph. And we can use more than just 2 features, of course, for multiple graphs. What we're doing here is we're plotting the features as y versus x, and we're plotting all of our samples onto the graph based on their values for feature 2 versus their values for feature 1. So if you had images, you could plot them all here. Then you are going to use principal component analysis to find the principal component 1 and principal component 2 in all of the inputs. So principal component analysis. Data is noisy, and therefore we need to produce dimensionality reduction, and that is the point of principal component analysis. We are reducing the dimensionality of our data because the data sets you have are typically going to be very large and very noisy, which means they have irrelevant data that's going to just mess with your network. It's going to be irrelevant to the actual results, but it's going to interfere with your results, like interference. And so because data is noisy, we have to clean it up, and we have to reduce its dimensionality, meaning we have to find the key features in your data. If we're trying to classify a cat versus a dog, we have to find the cat and the dog in an image. We have to ignore all the other noise in that image, such as a tree or a mouse. We have to look for only the key features in the image, and that is principal component analysis. We're getting each data points or each sample's first few important components. And in this way, we're going to make sure that we have data that is clean and that has the most relevant features in it. This way we can also reduce the size of our data, which is going to be a lot easier to work with than a huge piece of data. Like even an image that's 500 by 500 pixels wide and tall, well, that's still a huge image, because think about how many pixels are in that image. 500 times 500 pixels, and that is a lot of data per just one image. So we're going to learn a lot about principal component analysis in this course. We'll talk a lot about how we can get the key features from our data and from images in order to have less data and therefore the most important data only. With principal component analysis, we're getting each data point's few first components, and this is going to create what's known as lower dimensional data. That's what it means by reducing dimensionality. We're still preserving as much of the data's variation as possible, so we're still producing or preserving the key features of a cat and the key features of a dog, which is the data's variation, but we're just removing all the noise. We're getting only the most important features relevant to a cat and a dog. Then, next up, the second part of our unsupervised learning is cluster analysis. So let's talk about what cluster analysis is. We use cluster analysis to find commonalities in data. It will react based on the presence or absence of commonalities in every new input. So back to my example of cat versus dog, the model is going to react to the presence or absence of commonalities to a cat or a dog. So we'll look for commonalities in cats and commonalities in dogs. This way it will help detect data points that do not fit into any group. And those are the two features of unsupervised learning. In this lecture, you learned what are the applications of unsupervised learning, what is unsupervised learning, and what are the two key features or components of unsupervised learning. Awesome. Congratulations, everyone, and I will see you in our next lecture. Hello, everyone, and welcome back to our course. In this lecture, we're going to create a data set for our machine learning project. So here I am in Google Colab at colab.research.google.com, and I'm going to create a new code cell. I'm going to create a variable data, and I am going to create an array of data. It will be a multi-dimensional array where each subarray represents a row or an input sample. I'm going to have several instances here inside of this entry. So I'm going to have the label, such as here I'll have a label of A, and I'll have some string of text like this was fine. So what I'm creating here is a list of reviews. And this label A here, that is going to be for neutral, so we can just call it neutral actually. We're going to have another entry here. We can put in neutral again, and then we can say this was okay. Then we can have another entry for a positive and a negative review. So I'll have here negative, and then I'll have a string of text called this was bad. Then I'll have another entry for negative, and that is the label, and the value is going to be I did not like this. Following that, I'm going to have two entries for positive. So the label is positive, and the value is going to be this was good. Then I'll have a final one with the label positive, and the value is going to be I loved this. All right, so here we have 6 different entries in our data set. Now I want to create a pandas data frame out of this Python list. So I'm going to use pandas.dataframe in order to create a new data frame. In order to actually use pandas, we do have to import it. So let's make sure we import pandas at the top of the code cell. This pandas library is very commonly used because of its data frame type, right? So in order to create a data frame, I have to pass in here the data as well as the columns I want to create. So I'm going to have the first column be the label and the second column be the review. Okay, so we have the label, neutral, negative, or positive, and we have the review, which is the string. All right, and next up, let's now grab all the labels from that data frame. So let's make here our data frame variable. Okay, so we have a data frame variable that stores our pandas data frame. And next up, I'm going to then just get from that data frame the label column, and I'm going to store that as my labels. Then I can just print out the labels to verify that I have created it. So let's run this code cell now. And we should see just the labels column from our data frame. And look at that. Here are our labels. We can do the exact same to get the reviews if we're interested. All right, next I want to use the NumPy library to create a NumPy array out of the unique labels. That's what's going to be known as our number of clusters. So let me make here number of clusters. I'm going to use the NumPy library and use its unique function. But first, I do have to import NumPy. So NumPy is another very popular library used for data science and machine learning because it has the NumPy array type, which acts as a wrapper for the Python list, and it allows you to access more nuanced and complicated functions. And we need those for machine learning. All right, so we're going to pass in here labels. So we're only getting the unique labels. All right, then let's get the shape at index 0 because that's going to be the number of clusters. So let's print out number of clusters. If we run this code cell, we're going to get 3 because we have 3 unique labels. All right, now let's say we just printed out here numpy.unique labels. Then we ran that code cell. Well, then we get the unique labels, negative, neutral, and positive. All right, and just like that, we have built out our sample dummy data. And the goal of the project is going to be to use unsupervised learning to train a machine learning model to group these reviews. So the machine learning model is not going to see the label, it's only going to see the review, and it's going to have to classify the text into neutral, negative, or positive. The first step that we're going to have to take now that we've created the data set is to vectorize the text. Because in order for machine learning, for an algorithm to understand text, we have to convert the words, the English words, into some kind of mathematical numerical representation, and that's known as vectorization. So in the next lecture, we will learn how we can convert text into a vector. Hello everyone, and welcome back to our course. In the previous lecture, we created a data set, and in this lecture, we're going to learn how we can vectorize the text in that data set. So for that, I'm going to define a function, and I'm going to call this vectorize text. This is going to take in some sentences. The vocab is going to be by default none. We're going to have a minimum data frame value 0.0 as well as a maximum data frame value of 1.0. And then we're going to have an n-gram range, and it's going to be the shape 1, 1. So to build this vectorizer, we're going to have to first count the input sentences, transform them into a bag of words, and then fit the transform to the bag of words. So first, let's build a count vectorizer. Inside of this function, we're going to define here count vectorizer, and we're going to instantiate a new count vectorizer object. All right, so count vectorizer. This actually comes from scikit-learn, so we do have to import it at the top of the cell or the top of the file. So from sklearn.featureextraction.text, we're going to import this class, the count vectorizer. All right, so this is part of text feature extraction. We're getting features from data, in this case, text data. The scikit-learn, another very popular library for working with data science or machine learning because it has these very helpful classes like count vectorizer. All right, let's put this count vectorizer to use. Now, first, we do have to pass into it several arguments. It's required by the class. Okay, so I'm going to pass in here the max df, which is going to equal the max df that was passed into vectorized text. Same with min df. It's going to be the same argument that was passed in to the function. Then the vocabulary is going to be the vocab if it's passed in. And the n-gram range is going to be 1 by 1. So the same as what's passed in. Okay, then we can actually use this count vectorizer, I'm going to fit it to the sentences that we pass it, and the result is going to be the sentences vectorized. So I'll call this sentences vectorized. All right. Next, I have to then get the feature names. So I'm going to grab sentences vectorized and call get feature names on that. The result is going to be feature names, a variable that we'll create. Then we have to get a bag of words out of the sentences. So I'm going to take sentences vectorized, and I'm going to use the function transform, and I'm going to transform it with the sentences. This is going to return for me a bag of words, so all of the words in the sentences. Then I can use the pandas library again and create a data frame one more time. I'm making a data frame this time out of the bag of words .toDense, and the columns are going to be the feature names. This is going to return for me a data frame of my bag of words. So I can just assign it to equal that. Okay, great. Next, now that we have a bag of words, we have to transform that bag of words into a matrix. So for that, I'm going to use a transformer known as the TFID transformer. Now we do have to import this transformer. It will transform a bag of words into a matrix. So let's make sure that we import it right here. It also comes from scikit-learn.featureextraction.txt, so we can actually just add it to the list, TFID transformer. All right, so make sure you have that imported alongside count vectorizer. Then we can put this to use. So this transformer, okay, let's save it in a variable. We'll save this instance as our transformer. And then we're going to take that transformer and use its fit transform function to fit it to the bag of words. This will return for us a matrix. So let me call this our words matrix. It's a TensorFlow IDF matrix. Now we can find the most popular words with the highest weights as well. So for each word in every column, let's add all of the row counts. So we're going to count the number of times that words appear to find the most frequently used words. For that, I'm going to use numpy.asArray, and I'm going to pass in my bag of words and sum up on the 0th axis, then ravel it and convert it to a list. The result of this is going to be my word counts. All right. Next, I want to make a data frame that is going to contain the word and the number of time it appears. So I'll use pandas.dataframe again, and I'm going to pass in here a key word. The column word will be the feature names, and the key or column count is going to be word counts. All right, the result of this is going to be a data frame, and I'll call this data frame counts because it's the data frame of the frequency of words. Then I can sort all of those in ascending order. So I'll take data frame counts and I'll call sort values. I'm going to pass in count and I'm going to sort it with ascending equals false, meaning it will be sorted in descending order. And then I'll just reassign data frame counts to equal that, so it will be sorted. After that, I have to then build word weights. So let's create a variable weights, and we are going to use numpy again. We're going to use the numpy.asArray function. We're going to pass in here our words matrix dot mean at the 0th axis. So we're getting the average on the 0th axis. We're going to ravel that and then convert it to a list. The result of this is our weights. So we have our word weights as a list. Then let's make a pandas data frame out of those weights. So the word key is going to be our feature names, and the weight key is going to be our weights. That way we'll have a word and a weight for each word, and the result will be a data frame weights. So we're just taking the weights and we're converting them to a data frame. Then we do have to sort the weights because we want them in descending order as well. So we'll have data frame weights, and we're going to use the sort values function. We're passing in the weight because we're sorting by that weight column, and ascending is equal to false again because we want descending order. And then we'll just reassign data frame weights to now be sorted. All right, then we want to merge our weights with our counts. So we want to merge the two data frames. I'm going to take data frame weights, and I'm going to call the merge function, merge it with data frame counts. Okay, just make sure you have it called counts. Where do we want to merge it? We want to merge it on the word column, and how is left, meaning we're going to first take the weights and then we will take the counts. Okay, and the result we'll just store it in data frame weights. All right, and that is going to combine our two pandas data frames. Then we're going to use cosine similarity to find the similarity of sentences. So I'll call cosine similarity, and I'm going to call it on my matrix. Let's see, our words matrix with itself. So we're just finding the similarity of words in that matrix, and the result will be our, let's see, our word similarity. Okay, and cosine similarity we can just use like this, just call the function, but we do have to import it. So let's go to the top of our cell here, and let's make sure that we import that cosine similarity. This comes from sklearn.metrics.pairwise. We have to import that cosine similarity function, and that will allow us to use it. All right, so yes, make sure you have that imported. Okay, so now we have word similarity. Next, we want to find the distance matrix of sentences. So, take their similarity and then plot them. So we can plot how similar they are, because they'll be farther away on a graph if they're less similar. So I'm going to create here distance matrix. That is going to equal 1 minus the word similarity. Then this function, I want to return all that I just created. So let's return here our count vectorizer's results, which is our sentences vectorized, because we're going to need all of this for our machine learning. We need the sentences vectorized. We also need our feature names, as well as our data frame bag of words. And let's see, what else do we need? Well, we want to return everything that we just created. Our data frame bag of words, as well I want to return my matrix, my words matrix, and my data frame weights, and followed by my similarity, which I stored in word similarity. And after word similarity, finally, I want to store the distance matrix as well. Okay, so that way we'll have access to all of those values. And that is what we need in order to vectorize our text. So you can see it takes several steps to vectorize our text. So then later on, we'll be able to call this function vectorize text on our sentences. So we can actually just do that now. Let's run that code cell. So the function is created. Oh, it looks like we have to import TF-ID transformer. Let's just make sure we call that correct. Let's see, TF-ID transformer. When we import this, we have to make sure that we import it correctly. Oh yes, we just need an F here, TF-ID-F. Okay, so just make sure you call this TF-ID-F. I accidentally called it TF-ID. Okay, then you can rerun that code cell, and we also have to import cosine similarity. Just make sure, again, it's spelled exactly the same from sklearn.metrics.pairwise. Yes, that is where it comes from. We want to import that cosine similarity. Okay, yes, I just spelled it wrong. Oh, gosh, you have to be very, very careful when you are importing these modules and these functions. Okay, great. So once you have spelled everything exactly as expected, then you can run that code cell. And then we can put that code cell to use, so we can see it in action. First, we have to create our sentences. So let's make a sentences variable. And what is our sentences? Well, it's actually our data frame that we created earlier. So let's see, where is that data frame that we created? We created this data frame up here. Okay, it contains our labels and our reviews, all of them. We just took that and we converted it into a data frame. Now we want to take that data frame and just get the sentences from that.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.